All right, well, I've got 10 o'clock here. Go ahead and get started. Thank you everybody for joining us. Today, we're going to be talking about Innovent's new ACCUBLOC energy management product. And I'm joined today by Jake Sayward, Innovent's product manager, who's got 18 years experience in the HVAC industry. And he's going to be walking us through how, Innovent with ACCUBLOC can get up to 95% energy recovery with no preheat and no frost control needed. Jake, thank you for being here with us this morning.
Yeah, thanks, Aaron. Well, like Aaron said, I am the product manager for Innovent. I've been in this industry for many, many years. Innovent is a manufacturer of custom energy recovery equipment, custom package refrigeration equipment, and then we do a specialty custom pool unit using outdoor air for dehumidification. And my guess is that in Colorado, most of you that have had experience with Innovent, it's probably been around pools. We've been very successful in your climate. What we're here to talk about today is the ACCUBLOC heat exchanger. This is a component that we're starting to use inside of our equipment. So this is not just an energy recovery device. Energy recovery unit is going to be part of a custom unit with package refrigeration, heating, controls, all of the things that make our units what they are. ACCUBLOC is an ultra efficient, sensible, and latent energy recovery device. It's capable of operating at sensible efficiencies up to 95%, and then it does not require any form of frost control. The media of the heat exchanger, we're going to get into some more of the specifics of this, but the media is very similar to what you'd see if you went up to an enthalpy wheel and looked at that. It's tightly packed aluminum corrugate that is either mill finished, or you can get it with a desiccant coating on it as well for latent transfer in summer. Alone by itself, the aluminum media will actually transfer latent energy in winter. And we'll talk a little bit about that as we get deeper into the presentation. However, unlike an enthalpy wheel, the media doesn't rotate, it's fixed in place. What we're going to end up doing is, instead of rotating the media, we're changing the airflow over a 20-second cycle. So we'll essentially charge the media for 20 seconds, and then the airflow will reverse through it and discharge the energy that we put into it. So it's changing the airflow through the static media instead of rotating like a wheel would. The way these heat exchangers are laid out, as you see here, is you actually have two independent banks of the heat exchanger media. And in this case, we have a partition that's vertical. So you're not transferring air from left to right on this unit. The banks are independent. You also see that upstream and downstream, there's going to be two banks of dampers to control airflow. And in this particular example, this would be suitable for an over-under energy recovery unit. So your top section is going to could be outdoor air in this case, and then that would flow through the unit and come out the bottom as supply air. I'll show you an animation here in a second that'll explain that a little better. The ACCUBLOC has the benefit of, we can actually do this with two horizontal heat exchangers, so we can do side-by-side airflow arrangements as well, depending on if that's better for a particular project. So hopefully everybody can see this bit of media that's going to play. I'll go through this slowly and stop it as we go. But here, so over that 20-second cycle, what it's going to do is flip the dampers in each one of these airflows. So if I start here, if you focus on the outdoor air side of this, you can see outdoor air is going through one side of the damper. So it's actually, all that air is going to be taking on heat in winter time from the far bank of the heat exchanger. When it goes through this damper, it's actually opening up the airflow once it goes through the heat exchanger to double the height of that. And then it's coming through on the bottom side, on the far damper on the supply air. So it's similar in layout to a cross flow heat exchanger. And that's just the way it flows to the media. And you can see once the dampers flip, now what's going to happen is the outdoor air is actually going to go through the other side of the heat exchanger. And the same thing's happening here. It's going to go through this damper. It's going to open up into the full height at a much slower velocity, and then go through the bottom here on the discharge. Return air and exhaust air do the exact same thing. It's just the opposite heat exchanger. So every 20 seconds, this is going to cycle, and then that is a point that can be controlled as well. So you could actually slow it down and modulate the capacity, especially for an economizer type condition. So a number of questions come up when we talk about this technology. I guess the first one is, how is it possible that it can be so efficient? Well, there's a lot of surface area with this heat exchanger. Also, when you're talking about a rectangle, you're using that, or square, you're using the entire face area of an air handler versus a wheel that's going to be a little bit smaller. And then just that process of switching the airflows and having a cold bank and a hot bank back and forth is a very efficient process. Now, a lot of times efficiency comes at the cost of more static pressure drop. You know, typically we're designing these for about 3/4 of an inch to an inch of pressure loss. So it's not too far out of bounds of what you'd expect from an enthalpy wheel or a flat plate heat exchanger for that matter. Another question that comes up is, well, does this mean that my discharge air temperatures fluctuate? And the answer is yes, they have to, but there's enough control in it, enough, I guess, but for lack of a better term, thermal mass, that it really doesn't affect the overall performance. This is a sample of an output from a test that the ACCUBLOC manufacturers ran. You can see at the bottom here, this is actually in yellow, that is exhaust air temperatures. That has the widest band of fluctuation, but it's still only a couple different degrees. The supply heat exchanger, the most important one, is a much smaller band, and you can see that the temperature in the orange, the solid orange line, is taken at right after the heat exchanger. If we get 10 feet downstream, it smooths itself out quite a bit. And remember, this is going to be included in a unit that's going to have heating and fans in it. So you're going to essentially mix it inside the unit by the time it gets to the discharge. Mentioned before that frost control is not needed with this device, and it's a valid question of, well, how does that possible? In normal operation at cold climates, you're actually going to get condensate that starts forming in your return air. But because that cycle flips every 20 seconds, as that outdoor air comes in and actually starts to heat up, it's going to take on all of that condensate and evaporate it into the airstream. So what ends up happening is you actually end up retaining the moisture that normally you'd be exhausting into the atmosphere. So what ACCUBLOC has seen is that in many applications, it retains a higher space humidity, even when it's not mechanically humidified, just by the fact that you're not exhausting it out and then you keep recapturing it. So it all has to do with the cycle. That's why a form of frost control isn't required. Now, there is an ambient temperature where we do like to start talking about frost control. It's about -40. Below that, what we see and what ACCUBLOC has seen is that you can actually get frost and accumulation on the exhaust airstream side, not the heat exchanger, but actually downstream of it. It just becomes so cold that it has to be addressed. But you know, in Colorado, I don't think we're looking at temperatures that cold. Best way to show the performance of this is with comparing it to a wheel. You know, if I take a 10,000 CFM example at 10 degrees ambient, the reason I chose 10 is because that's typically close to the threshold of where below that a wheel might actually freeze, especially if a space is humidified. And I just use 72 degrees, 35% relative humidity coming off from the return. if you take a look at this performance, I ended up selecting about an 84-inch diameter wheel with 0.61 inches water gauge, so a little bit less than what we would do with an ACCUBLOC. The ACCUBLOC is larger at 94 by 94, has a little more pressure drop, but look at the sensible efficiency between these two. So we're talking 90% efficient. Yes, we could drive this up to get to 95%, but truthfully, the sweet spot in terms of overall cost is probably more around 90, 91% sensible. So I chose to do that with this selection. The thing that really stands out that I always like to show people, however, is the supply air temperature. So that wheel at 10 degrees is going to get you to about 56.5 degrees. That's going to be cold. If you dump that straight into a space, it's going to need to be tempered. It's going to be too cold in winter. With the ACCUBLOC, we're getting all the way up to 64 degrees. You're getting close to the point where maybe you don't need much, if any, mechanical heat from your ventilation air. You might be able to do it actually with whatever you have going on in the space if there's a decoupled system. Why that is important has to do with applications. This is definitely a product that makes the most sense in cold climates. ACCUBLOC has had a lot of success in Canada, and that makes sense. It's just cold climates, and you can get a tremendous amount of the heat in the heating months. I should add that this heat exchanger operates very similarly to an enthalpy wheel or a flat plate heat exchanger in summertime. Obviously, high outdoor air requirements. It's very, very good at when you pair it with a decoupled system like a VRF system or water source heat pumps or some other decoupled mode of heating and cooling. And then as we start to see more and more of a push for electrification and reducing carbon emissions, this can really cut down on the amount of heat that you need in winter. I showed you that 64 degree leaving air temperature. It's a lot easier to build an air source heat pump to do a small temperature rise than it is for another 5 or 10 degrees off of that. It's also a lot less expensive just to use an electric resistance heater. So it really opens up a lot more options when you're talking about trying to reduce carbon emissions. So we're excited to see how this is going to play out with that becoming a big push, because I think this technology is going to be something that will help us get there. There are some places where this is not intended to be used. It does have cross-contamination like an enthalpy wheel would. It's because when it's flipping the dampers, you're going to have air lost in that section, and it'll flow the other way. So it's about 2 to 4%. Anything that has so because of that, it doesn't make sense to be using this for any type of dirty or contaminated air. Process applications are not good. Anything like a pool that has a high level of humidity in the space, again, not a good application, just because you're going to have so much moisture that's actually going to be trying to get put back into the airstream on the supply side. It just doesn't make sense. So again, I know that's like a very, very brief overview. Usually we give this presentation in an hour or so and get really deep into how it works and more information on it. But think of ACCUBLOC as just another option of energy recovery that's very, very efficient, great for electrification efforts, very high sensible efficiencies. It can do 95%, but truthfully 90, 91 is probably the sweet spot. And then you really don't need to worry about any type of frost control. So this can operate down to very, very cold temperatures. Because there's a lot of things I wanted to get to, it just didn't have the time. I put together just some very quick questions at the end in case you have them. I guess the first one is, how long has this technology been in the market? Why haven't I heard of it yet? Well, this is a product that was actually developed in Europe. It's been used for probably 30 years there now. I've asked the question of why we're just starting to see it now. And the best answer I've gotten, and it makes sense, is that the energy cost in Europe is much higher than what we have here. Also, it tends to be more heating focused from an energy recovery standpoint. So they're willing to look at a 90% plus energy recovery device and invest in it. If we're talking about face area for efficiency, can't I just make a wheel or a plate do that and just keep ratcheting up how much surface area I have. You can, but there's a diminishing return. We've done a number of different trials where we've compared the two, and you really start to max out on an enthalpy wheel at like 85%, and that's a huge wheel. Your velocity gets really low and it just becomes difficult to control. So it's just not really a feasible solution. Questions on the dampers. It's an industrial damper set that's manufactured by a company out of Italy. It does not use normal actuators like we have here in the United States. It actually is with a motor and a gearbox. So it's meant to flip very quickly. And it's designed for millions of cycles. So it's a little bit different technology than what we would see here, but it's still, replacement parts and things like that are still easily and readily available. From a maintenance standpoint, there's not a lot you need to do with the heat exchanger because you're going to do pre-filtration on both sides on the inlets. So you're going to be cleaning the air, but it can be cleaned like any other enthalpy wheel with water or steam. And then the dampers over time, just making sure that they're functioning correctly and the motor's operating like it should. The ACCUBLOC is not AHRI certified, and it's just because there's no category for it here in the United States. And then I mentioned earlier about capacity modulation or economizer. Yes, we actually give a 0 to 10 volt input to the controller of this device, and that'll back off on the amount of time that's in that cycle. So 20 seconds is 100% capacity. We can back that down. And by doing that, we're going to essentially just reduce the capacity to either hit a certain leaving air temperature set point or allow free cooling. And then we're just flipping it to make sure that we're not getting the heat exchangers dirty or anything like that.
That was great. That was a lot of information, Jake. Appreciate that. And on a day like today, where we're about -2 this morning, this type of product could make a lot of sense. And I appreciate everybody for joining today. And don't forget to join us again next week, next Thursday, for Andrew Tobin's coffee break next week. Appreciate everybody being on. Thanks, Jake.
Thanks, guys.
Bye.